So, hello everyone, welcome to the second session of Firebase for Web. So, in session one, we learned about, uh, we basically saw the fundamentals of web development, that is, what is the structure of web application, then HTML, CSS, and JavaScript. We all saw fundamentals of both this, all of these three, what you can say, components. So, uh, let's start with our let's start with our today's session. I'll share my screen just a minute. So in today's session, we are going to look at Angular. But before looking at Angular, we required a bit knowledge of TypeScript. So before moving on to Angular, we'll first see what is TypeScript. So what is TypeScript? A TypeScript, basically, a TypeScript is an object-oriented programming design or created by Microsoft. It is basically a typed superset of JavaScript. It is a language built upon on JavaScript. It adds new features to it adds new features, and there are some advantages over JavaScript of using TypeScript, such as in TypeScript there's type checking, or there are new what we can say, we can use modules and generics in TypeScript, but uh, we cannot execute TypeScript in our browser. Our browser can't read TypeScript. So basically, we need to compile down TypeScript into a JavaScript code. It is also known as transpilation. For example, so we transpiled our TypeScript code into JavaScript. That is, whatever we write the code in TypeScript, there's a compiler which compiles that TypeScript code into JavaScript, and after that, it executes in our browser. So one question can come is that why to use TypeScript, right? After all, we are converting TypeScript into JavaScript, and after that, we are running in a browser. So why use TypeScript? Why can't we use only JavaScript? So basically, why not only JavaScript is JavaScript is not originally designed for large complex applications. It's mostly a scripting language fundamental with fundamental programming structures, and it lacks a structuring mechanism like class, module, interface. Along with that, there is no type checking in JavaScript as well. For example, here's a example. For example, if we execute this function add, and uh, if we pass an input string to this function, it will uh, it will give you an unwanted output. For example, it will just concatenate the two strings, which is not we wanted. We wanted addition of two numbers. So if we execute this code in JavaScript, it won't give you error. But if we execute it in TypeScript, it won't allow us to pass the string. Here as well, it prevents an unwanted behavior at runtime, so that TypeScript helps us. to what we can say, to prevent such runtime errors, or to prevent strategies to check whether the input we are passing are actually a type number or not. So for this, TypeScript is beneficial, or what we can say, it's an advantage over JavaScript. So let's look at an example of TypeScript. Okay, so this is a basic. I have written the code index.html and index.js, where um, what we are doing is we are taking an input from user. Yeah, so we are taking an input from user, and after that, uh, we are basically using a, okay, we are taking two numbers as input, basic HTML code, and after that we are executing an add function, and we are passing those two input, and we are just resulting out the output. So if we click add, so what it does is it does not add the two numbers, it just concatenate. It takes input as a number, but when we what we can say, when we access the value using document.getElementId, it provides that value as a string. So this was a runtime issue. So we didn't able to catch this issue unless and until we run the code. But using TypeScript, we can, what we can say, we don't have to run the code. We can just we can identify the problem in our browser as well, in our IDE only. That is, for me, I am using Visual Studio as my IDE. You can use any. There are many IDEs available. So let's look at how to use what we can say, how to use TypeScript. So before using TypeScript, we need to install TypeScript, and for that we require Node Packaging Manager. For that we require Node.js. So this is a Node.js page. You can download Node.js, and when we install Node.js, it automatically installed npm as well, Node Packaging Manager. So after that, we need to install TypeScript. I'll just run the command. So yeah, so let's just write TypeScript. Let's write some TypeScript code. For example, I'll create a file with extension ts, that is type.ts. And as what we can say, as TypeScript is a superset of JavaScript, all the all the JavaScript code which we write is valid in TypeScript as well. So yeah, it gives so here in TypeScript it gives you error that property value does not exist on HTML element. So for that, uh, why the what we can say ID is giving you this error, because the property value does not exist on all the HTML elements. It exists only on input elements. So we need to specify that HTML input element. So while defining num1 and num2, we need to explicitly tell the IDE that it is an input element, and after that it won't give you error. Similarly, we can add here a type check for function. For example, only want number to be passed to this function, so that the parameters which are passing to the add function must be numbers. So we can add a type checking for this function as well. So here it will show us the error that string is not assignable to parameter of type number. So we need to convert whatever the value in this is to a number. For that, uh, in JavaScript as well, we can just add plus to plus before the variable. It automatically converts the whatever the value in that variable into the string, into the number, integer or integer number. So now it's again showing that number is not assignable to string. So whatever the output of our addition function, add function is, it's a number, but we cannot assign it to inner HTML property as it requires to string. So we need to convert this to string using toString method. So let's just after that let's just compile this type.ps file. Uh, to do that, use tsc and give the path of your file, that is type.ps. After that, it will compile the TypeScript code and it will generate a JavaScript file. Now we can run this JavaScript file in our HTML code, for example. So it will give you a correct addition, that is 76. So this was all a little bit of TypeScript, how we write TypeScript, or how we what we can say, how we uh, use type checking, typecasting. This is basically a typecasting in TypeScript. So let's just continue with the. So this was all, and this was an example. So that here we can TypeScript provides a tool that helps developers to write a better and clean code. So we just saw a type number, right? We were we are typecasting the variable parameters of add function like number. So what are other different types in TypeScript? That is what types, what data types TypeScript supports. So these are different type annotations in TypeScript. For example, there's a any type. Any type is a superset of all types. For example, if we define an variable x with data type any, we can what we can say, we can pass any value to x. We can give value string to x as well, and we can pass integer as well to x. So after that, there's a primitive, that is predefined data types in TypeScript. Number, we just saw number, right? Uh, it for all different. There does like just like CPP, we does not have to explicitly define that this is a float or this is a double type or this is an integer. We just have to define number. So whatever the value, whatever the number is, whether it is integer, float, we just have to define number in TypeScript. Other than that, there's a string data type. Then there's a boolean, bol. Then there's a void. In CPP and other languages also, if our function does not return anything, we the type of that function is void. After that, object types like class, interface. Other than that, there's an array type as well. So to declare an array, we use this syntax. For example, var list number, and open and closed square brackets. Instead of number, we can use string as well, that is a array of string. Similarly, we can also use this syntax as well, array, and in uh, arrow, and in arrows providing a type, that is number string. After that there's an enum, enumeration, and after that a tuple. A tuple is basically a array with fixed length. For example, if we know that the whatever the array we have has two elements, and of which one is string and one number, so we can use tuple as our annotation. So another, what we can say, let's just write some different types of annotations. For example, let's say uh, is true, uh, is equal to true. So we can see let is true is a boolean value, and now we cannot uh, assign any different value to this, as for to this variable. It will show an error that string is not assignable to type boolean. Similarly, this was for true. Similarly, we can use a string as well. If it is a string, we can assign it. But if we does not define anything, we just write let is true. Automatically, its type will be any. Then we can assign string to it. Other than that, we can assign a number, then boolean as well. So generally, we don't use any. We generally use a specific data type, so that we what we can say, so that problems like this we can identify it easily. So that was all about TypeScript. Let's just see now. Let's just move on to Angular. What is Angular? So basically, Angular is a platform. Angular is a platform and a framework for building single page client application using HTML and TypeScript. Angular is a Angular is written in TypeScript. It implements core and optional functionality as a set of TypeScript libraries that you import into your what we can say application. So, but basically, it is a SPA framework. It is open source. It is helpful in data binding as well, and it is made up of or consists of components and modularized. So what is SPA? SPA is single page application, but what is the main difference between traditional web app and a single page application? Traditional web app means whatever we saw in our first session, that is basic application using HTML, CSS, and JavaScript, and that was a traditional application. So what is the main difference? What makes Angular different than web application? So as you can see that uh, in traditional web app, our browser sends an HTTP request to a web server, and after that web server sends a full HTML page, and it will render that HTML page in browser. Whereas in single page application, what browser there's an HTTP client in browser, and it sends a request to the HTTP web server, and web server just passes JSON data instead of passing whole HTML page. It just passes data, and using that data, HTTP client changes the page and shows the, what we can say, the page. So SPAs, that is single page applications, are faster than traditional web application because they execute the logic in web browser itself. Here you can see that HTTP client, whatever the logic of our application, its browser itself executes it. So it's faster than the server. Then it is faster than whatever the what we can say, whatever the logic happens in server. So in traditional web app, logic is happened in server. But whereas in single page application, logic implementation is happened in browser itself, so it's a faster. Only data is sent back, that is the JSON data is sent. So only JSON data is sent forth and back and forth. So and after the that is first the initial page is load, and after the initial page gets load, only data is sent back forth, uh, sent back and forth instead of entire HTML page. So it's a faster. Benefits of single page applications are some. Single page applications are smooth and fast. They are easy to deploy and develop as well. And we also debug, and we can also easily debug single page application. So these are some features of Angular. First is data binding and fastest load. As I said, binding, two-way data binding is an important feature of Angular. So what it does is it binds property and event at the same time. We'll look at data binding in our further session. Other than that, it's a one page application, that is single page application. Then there's an flexible development. So Angular provides an Angular CLI, that is command line interface, which makes our work easily. So like 50% of our work is done by CLI only, Angular CLI. That is, it also therefore it provides in flexibility in development as well. After and other than that, it Angular applications are made for large scale user application. Therefore, it supports maximum users. Whereas as it is a single page application, the speed and performance is quite high and very good in Angular. And also simple, and we can create a simple and expressive UI using first library which Angular provides us. Other than that, it's a cross platform. If we create a PWA using Angular, we can run it on iOS, Android, desktop using a single code base. And other than that, it's a simplified MVC pattern. Whatever the model view controller architecture is there, it's a simplified version of MVC architecture. So let's look at key parts of Angular. What are the key parts of Angular? So first and foremost, it's components. So components, other than that, there's a templates, and uh, after that there's a dependency injection, and after that there's a routing. Routing is an important part of Angular as well. As Angular has made routing easily for us, we can easily navigate between our pages, between our components. So let's look at uh, all the parts one by one. First is components. So this is an example of component. This is how a component looks like. So a component consists of mainly two parts: a selector and a template. Selector, a CSS selector that defines how the component is used in a template. For example, this is an hello world component. How we can render this hello world in our template using the this is the work which selector shows us how to use this component. And other than that, there's a template in component, a HTML template that instructs Angular how to render the component. So whatever we write, or h2 or paragraph tag, or whatever input element we have in our application or image, we all write it in template. Next part is templates. So every component has an HTML element that declares how that component renders. So as you can see here, it is a component. In here, there is a selector and template URL. So in this, in last example, we saw that we have written whatever the p tag or heading tag here as well, but use that in we can write it in another file as well, and just provide a path to that file here in template URL. And also we can access whatever the data or whatever the variable we are defining in class. For example, here you, if you saw, here's a message key variable whose value is hello world. We can access this variable in component.html file using two curly braces. So other than the dependency injection, dependency injection lets you declare the dependencies of your TypeScript classes without having to worry about their initialization. So dependencies are nothing but services or objects that a class needs to perform its function. Dependency injection or DI is a design pattern in which class requests dependencies from external sources rather than creating them. And Angular's DI framework provides dependencies to class upon instantiation. That is initialization. Sorry. At the initialization of class, it provides the dependencies to the whatever dependency is required. So use of Angular DI to increase flexibility and angularity in your application makes it very important. Other than that, there's an I mentioned earlier that Angular CLI. Angular CLI is a straightforward and recommended way to develop any Angular application. It Angular CLI, what we can say, makes our task trouble free. There are different commands which we can use. For example, ng build. It compiles an Angular app into an output directory with a single index.html file as an output, which we can use to uh, what we can say, which we can use to deploy our code on any server. Other than that, there's an ng server. It basically builds and serves your application on your local server, and we can see the local hosted app on port 4200. Other than that, we can generate components and services using ng generate command. Other than that, we have ng test to run some tests on our or our application. Then there's ng e2e command as well. So let's take a look at Angular application. So I will visit Angular page, angular.io. So it's what we can say, cover page of Angular. Let's get started. Then setup. Yeah. So these are the prerequisites for Angular framework. So let's just install Angular CLI first. So after finishing, you can check it using ng v command. It will show the version of CLI. That is my Angular version is currently 12.0.3. So let's just create a new app using ng new command. So I'll create ng new. I will give the name Angular app. So it will ask, would you like to add an Angular routing? So I'll just say yes. And after that, it will ask which style sheet format would you like to use. So let's just select normal CSS. After that, it will create a bunch of files for you. That is, it's basically create a whole structure of Angular application and with an example of what we can say, a basic example of Angular, which we can just serve and see what it looks like. So it will take some time. So as I mentioned earlier, and this is an what we can say Angular CLI. It does most of the work for you. It creates this all file for you inbuiltly. That is, you don't have to write explicitly your file, so you don't need to create this all such file. It will provide you all that file. You just need to write, or you just need to use these files and write the logic in these files. So this is till it let's just see some user documentation while it creates our app. Let's just look at the site that Angular has provided us. So here we Angular has provided with us all, what we can say, all the information we required to get started. For example, setup, understanding Angular. We can use this site as well if we want to uh, what we can say, learn Angular professionally. So we can use angular.io. There's a documentation, well guided documentation here, which helps us to write a full-fledged Angular app with all the necessities. So yeah, so it's done, I guess. Our app has created. So let's just change the directory into that. What was the name? Angular app, right? So after changing, after what you can say, going to our application, let's just run ngserve command. So what ngserve does is it's basically bundles up your TypeScript code into compiles it into JavaScript and creates a whole, what you can say, a dish directory in which it creates a single page application and serve it on our localhost, which you can see on a port 4200. It's basically just browser. Yeah, it's done. So let's just visit localhost 4200. So yeah, this is a basic, what we can say, basic application or basic template that Angular with provides you initially. So using, there's a there's different command. For example, to generate a component, there's this command. Along with that, there's a different library as well. So let's just take a look at what Angular application looks like, or what is the structure of Angular application. So I'll just open this directory that we have just created in Visual Studio Code. So yeah, so you can see all these files, right? All these files are created by Angular CLI. So basically, this is a tsconfig.json. This is basically, this file is for compiler, the compiler which we use to which compiles all our TypeScript files into JavaScript. So basically, these are settings for that compiler. This is a basic package.json where you will see all the dependencies for our application. For other than that, this karma.conf.js, this all other files are used for testing purposes. So let's just look into the what we can say, structure of our file. So index.html. So this is our root, what we can say, root index.html file, and this is the entry point for our application app root. So this app root is the component. This is one Angular component which is defined in our this app directory. So you can see here there are bunch of files like module.ts, component.cs, of which app.component.html is one, where all this code has written. So whatever we are looking here is all in this file. So basically there are what we can say three main types of files in an Angular: a component.html, where we write all our template, whatever our HTML code is there, whatever divs, input element, we all write it in component.html. Whereas in a component.css we write all CSS file, all the CSS code. For example, uh, here they have written it in this style. Here they have written in this style, but instead of style we write this all code in component.css file. And whereas component.ts, here where we write all of our logic of code, like for traditional web app we use JavaScript. That is, we all whatever the logic is there we write in index.js, that is JavaScript file. Similarly, whatever the JavaScript we use, whatever the JavaScript we write in index.js in our traditional app, we write TypeScript in component.ts file. So whatever the logic, whatever if we want to check any whatever the event listeners are there, if we want to click listen a click event or whatever the JavaScript code, right, we similarly write a TypeScript code in component.ts. Whereas component, these are specifications for our TypeScript files. And whereas this is a app routing module, initially this is where we use this file we use for routing of our application. So let's just clear the app.html file and write some our own code. So I'll just clear all this file. And our Angular CLI, it reloads whatever we make changes, it reloads and serve the pages onto the server, that is localhost. So okay, so let's just see the component types, component.ts file. So one, what we can say, what earlier I said that whatever the variable we define in component.ts file, which we can use this variable value in our HTML file as well. So if I want to use this title in our component.html, I can just write here a p tag. I just write a p tag, and using double curly bracket, I can use the title variable. Yep. So here we can see Angular app name. So if I change this value to hello world, so yeah, this is again, this is one use of Angular. What we can say, we can directly use whatever the variables we have here in our component.html. So other than that, there's an we learned a term, what you can say, binding, data binding. We can also use two-way binding in Angular. I'll show you the example. So let's just create an input element with type text. Okay. So now I have to bind this input variable to this paragraph tag. That is what I didn't say. So now I have to bind. So whatever I write here should be shown in this paragraph tag. So let's just uh, what we can say. Let's just bind these two variables. So using two-way binding, we first need to what we can say, we'll require, there's Angular provides us a directive named ng modal. So we need to use that ng model. So before using that ng model, we required a dependency. So for that we need to use dependency injection. For example, I'll just use here forms module. So whatever this forms module is, it provides us an ability, or this is basically what we have done is dependency injection. We have injected a dependency named forms module, which will allow us to bind the data. So let's just bind that data. I'll take this paragraph below. After that, let's just use ng model. So this is a basically syntax for ng model, and now I'll bind this whatever the input text value is to this to the variable name title. So I'll just write here title. So what we are doing is basically this is a two-way binding. Let's just see if it works, right? So see, it works. Whatever we write here, Angular app, it just bind that data and output it in paragraph. So what we have done is we are basically binding. First, we are binding an event, which that is whatever key we are pressing on our keyboard. There's an every key there has and there's an event. So basically, we are binding that event with a what we can say a property title. We are binding that event with property. Therefore, it's a two-way binding known as a property binding and event binding. So now let's just look at navigation. Let's just create a new component, generate a new component for our application. So for that, there's a command in ng generate component named what we can say. Let's just say demo. So our CLI has created a component named demo and all the necessary files required for that component. So now we can see a directory named demo in our application folder, whereas all the three basic files, that is component.html, component.css, and component.ts files have already been what we can say created by Angular CLI. So most of the work is done what we can say done by our Angular CLI. We just have to write the code. So let's just for example demo works. So now what if I want to use this component in our app.component HTML? So in component.ts there's a name selector. So I was saying that so using this name we can access this component in our HTML file. So if I write here app demo, so it will show you, it will render the component demo and it will show demo works. Similarly, what if I don't want to write this what you can say app demo here? Instead, I want to redirect our page to slash demo. For example, if I write here slash demo, it should show me demo works. So for now, it won't be showing me because I have removed that. So what if I want to route, that is Angular routing? If we want to use Angular routing, what if we want to show the whatever the demo component is on the demo, basically on this URL? So for that, there's a file in app, that is app.routing, app.routing.module.ts. So all basically all the work has done has provided by done. Only we have to provide a path and a component which we want to render at that path. So let's just create an object named path here, and for path I'll just say demo and component. What was that? Demo component, right? So our so we can see that if I click here, our ID or VS Code or whatever uh, ID you are using, it will auto import your the component, and we just have to save here. So now if I visit slash demo, it will show demo works. And all this is because of this router outlet. This component, because of this, we are able to, what we can say, render the demo app in our file. So this was all the basic structure of Angular, how Angular app look like, or how there are different, what we can say, dependencies which we can add, or how we can bind data between our TypeScript file and HTML file. So this was all about Angular CLI and Angular application. So other than that, Angular also provide us first party libraries like Angular router. We've just used Angular router for routing to our demo page. Similarly, other than that, there are very libraries provided by Angular, like Angular Forms for a uniform system of participation and validation. Also for making an HTTP clients server communication robust and powerful. Angular provides you HTTP client as well. Then there's an animations. Other than that, if we want to create a PWA, just like I mentioned, if we use a PWA as an Angular, it will be a cross-platform app. So we can use Angular for that as well. Angular provides a first-party library named Angular PWA. Then there's Angular schematics. So with all such, what we can say, libraries, creating an Angular application becomes an easy and flexible. So that was all for today. So if anyone having doubt regarding, uh, what we can say, Angular, you can ask in the chat, or if not, let's just end the session here. And thank you for attending the session.
Thank you, Piyush.